thoughts if you want to take something back to the people who couldn't make it here. In a traditional system, we have structure and meaning. We've designed things, we've made an employee master table, various other tables. But the problem is that we've baked the meaning into the structure. The way we do it with relational and object-oriented, you can't separate the meaning from the structure. They're just kind of cooked together. And it's the structure part of it that makes the system rigid. Because anytime you change some part of the structure of a system, you've got to change everything that it touched. You've got to change the code, you've got to change everything that's affected. So that's where the cost of change comes in. It's not because of what stuff means, it's because of how you structure it and how you have to deal with the structure. The other problem we've got in a traditional system is every time you want to make a new distinction, every time you want a new column or a new table or a new something, you have to get everybody together and they all have to agree. That's what the corporate information systems look like. Is how much agreement can you get? And then, if you can't get agreement, then you just leave things in unstructured fields and pass around memos and tell people, oh, by the way, an asterisk in column 27 means something. I just decided to give up on the structure thing. Well, that's what it is traditionally. In semantics, we separated the meaning from the structure. I'm going to talk about how we do that in just a second. We'll just kind of take that on faith for right now. And having done that, the structure we're left with is incredibly simple. We don't all have to agree on everything. We've got this mechanism now where agreement can be what we call modular and fractal. We can have little groups of people that agree on something. Some people may agree on everything, and other groups are just going to agree on what they agree on. Everybody's going to agree on everything. And that this whole problem of subtle distinctions, where we just decided to leave it in an unstructured field and send a memo around and hope the humans could figure it out. In place of that, we're going to have a mechanism for saying, I have a way to describe a subtle distinction. Here's what it looks like, and you can understand it. Once I've made up my concept, you'll be able to follow and understand. So maybe you're wondering, how are we going to do that? So what we're about to see is rarely shown, and it's partly because once you see it, it's too obvious to show, but until you see it, you go, oh, I wouldn't have thought of it like that. And that is, I'm going to show you the conceptual data model for the semantic web. So conceptual data model for a traditional system, hundreds, thousands, tens of thousands of concepts, tables, relationships, and all that kind of stuff. And if you can imagine something that has to scale up to the size of the semantic web to cover every conceivable site and everything else, what must it look like? Well, it turns out this is what it looks like. It looks like, conceptually anyway, one table with 3 columns. I call the columns subject, predicate, and object. Now, the actual physical implementation is much more complex than this. Sometimes they have between 4 and 8 columns, 2 or 3 tables. In the so-called triple store, there's usually more than 3 columns, but not a lot more. There's not tens of thousands of different tables. It's structurally different. So this is all there is. How does it work? I'm going to have a real quick primer on that here. Imagine I put some data in this table. In this case, I'm going to say that John McComb is the parent of Dave McComb. This little assertion, we call it triple. We usually draw it with ovals and arrows between the ovals. That's it. That's one assertion, one triple, one nugget of information. But it's what's in this that makes it kind of more interesting than just a plain old table with 3 columns. This thing on either end is a uniform resource identifier, a URI. For the moment, think of it like a URL. Cover that in just a second. It's an identifier that potentially could get resolved on the web. So that identifies some person in the world. John McComb in this case. There's another one. And, by the way, the URI isn't me, it just identifies me. And then this other one is more interesting. Now, this little colon here is a shorthand for a namespace. I'm going to blow that out in a second. But for right now, imagine that somebody somewhere, we're saying BR, let's say it stands for the birth registry. that somebody was keeping track of who was the parent of whom. You know, my wife is a midwife, so they do this kind of stuff. They keep track of who they think, anyway, the parent of somebody is. And what we're really saying here, when we attach a URI to a predicate,